Hello students, welcome to VB Academy. This is the second class of engineering materials. We are dealing with the mechanical properties. In first class we have covered with the strength, brittleness and the plasticity. Whatever the leftover properties, mechanical properties, we are going to cover in this class and the next classes. So what is meant by strength we came across in the first class, what is meant by plasticity and what is meant by brittleness we came across in the first class. So now we will proceed with the elasticity. Before going to that, I will let you know the tensile test, how the tensile test is done here. So before going with the tensile test, we will go with the one specimen. Specimen has some standards. Specimen means the testing material is known as specimen. On that we are going to perform the tension test. So in this tension test we will obtain different properties Nana here. First is ductility based on the percentage of elongation and reduction in the area, I will let you know. Then the malleability as well. Then coming to the resilience, toughness, all these properties we can obtain, means calculated or directly measured, we can obtain by the tensile test diagram. Tensile test diagrams, or we will call it as the tensile test based on the tensile test, or we can draw it from the stress strain diagram or the load versus deformation diagram. Okay, see here. So first property is elasticity. So what is meant by elasticity? So whenever the body is loaded, means externally loaded, if you apply any force on the body externally, it gets stretched, or deformation will be there in the body. And whenever you remove the load, means when you take out the load, if this body again goes to its original position, its original shape, its original size, then the body is known as elastic body, and the material with which the body is made is known as elastic material. Clear? So see here, first property is what Nana here? Elasticity. What is meant by elasticity Nana here? Say this is the body. This is the body on which I am applying the force which is pulling in nature. What Nana? Which is pulling in nature. Due to this application of the force, say this is the original length L0 or original length L0. When the force, external force, pulling force is applied on this body, what happens here? The body gets elongated. Body gets elongated like this, and the length will be say LF, and this is the P, means final length. But now this is the initial length and this is the final length. After applying, if you remove this load and body takes its original position, then that body is known as elastic body. What Nana? Elastic body. Clear? So what we are doing here for getting this property, elasticity, we are applying the force. All the mechanical properties are applied by what Nana? By application of the force, and knowing this behavior of material, we will get the mechanical properties. Elasticity is mean what? Ability of the material. What? Ability of the material to regain its original position whenever the load is removed. See here, I am writing the definition. What Nana? Elasticity is what? The ability of the material to regain its original position. What Nana? The ability of the material to regain its original position when the load is taken off or the removed. Position when load is removed. This is the elastic nature of the body. This is what Nana? Elastic nature of the body. Then coming to the next property, ductility Nana. What Nana? ductility. Ductility. What is meant by ductility? Ductility means it is the ability of the material to deform under tensile load without fracture. Without fracture. Due to this property only, ductile property only, we are drawing the wires. Means in ornaments, wires, thin wires we can draw due to this property. Means deformation of particular material under tensile load. Under tensile load is known as ductility. Are you getting my point? So whenever the tensile load means the load which is in pulling in nature is applied on the body, if it is deforming under the load, then that body is known as ductile body. Then for ductility, measure of ductility will be percentage of elongation and percentage of the reduction of the area. I will let you know that later. Okay, so what is meant by ductility here? What is meant by ductility here, Nana? The ability of the material, the ability of the material to deform under tensile load. What, Nana? Under tensile load. Or simply, it is the ability of material to draw into wires. Or the ability of material to draw into wires. Nana. It is the ability of the material to what? It is the ability of the material to draw into wires. To draw into wires means what here, Nana? You can check. These type of materials means ductile materials. You can apply whatever the pulling load you can apply on the this type of ductile material. These ductile materials are very strong in tensile nature. Means the tensile strength of this ductile material will be more. Clear? So you can apply these force only. These are very strong in tensile load. Means pulling nature. But these type of material means the ductile materials are very weak in the shear. Shear means here check what we are doing here. Say this is the body, Nana. This is the body. I am drawing it in 3D view. This is the body. This is the area of cross section here. You can check this is the area of cross section. If you apply the load perpendicular to area of cross section, then that is the normal load, or we call it as the axial load. What? If you apply the load which is perpendicular to area of cross section, we call it as normal load or the axial load. Why? Because why it is called as a normal means to the area of cross section it is perpendicular. That's why it is normal. And why it is called as axial means the axis, it is acting along the axis. Clear? So if you apply this normal load, it will deform easily. Means it is very strong along that tensile load. Then one more load you can apply here. Say I am elaborating means magnifying this diagram here. You can check. Say this is the area we got, area of cross section. Till now what we have applied the force which is perpendicular to this board. But now what I am doing is I am applying the load which is parallel to this board. Means along this area of cross section. Say knife, say or scissor. What we are doing here? So with the scissor, if I cut like this, what happened? It will cut easily. These type of ductile materials are weak in the shear. Means what is meant by shearing force here? If the load, check here, if the load is acting parallel to the area of cross section, then the load is known as shearing load, which causes the part or the body has to be divided into two parts. if you apply the shear force. Clear? Parallel force acting along the area of cross section. This is the area under shear, we call it as. This type of ductile materials are very weak in the shear. You can check how you can break the wire by applying two parallel forces. Say round wire is there and you are applying force, round wire, this is the round wire, you are applying the force. You can't break it by elongate it, you can break it by applying forces like this, shearing force or the cyclic loading. Clear? So that is what we call it as, these ductile materials are weak in the shear and is strong in the tensile. Means ductile material possess more tensile stress, more tensile strength. Then coming to the malleability. These are the different abilities of the material to deform under the compressive load. Malleability is what, Nana? Malleability is the ability of the material to deform under compressive loads or draw it into the sheets. Here wires, here the sheets. Here tensile load, here what? Compressive load. You are getting? What is meant by malleability here? Malleability is the ability of the material to deform under compressive load, means the load which is in the push nature. Clear? So here malleability means what? Malleability means the ability of the material to deform under pushing nature load. Clear? This is what? Pulling nature. This is what? Pushing nature. If you apply the pushing nature load, what happens? It will get thinner, means the area of cross section will get thinner and it forms into sheet. I am giving the one trick to remember it. What happened here? If you apply the compressive load, say you having the sponge. If you apply the compressive load, what happens? It will get thinner, means it forms like a sheet. Clear? So what is meant by malleability? Malleability is the ability of the material to deform into sheets or to deform under compressive loads is the malleability. Clear? So see here, Nana, the ability of the material, to deform under what, Nana? Ability of the material to deform under compressive loads. Hope you got the difference between compressive and tensile load, right? So compressive load or ability to drawn in sheets. Ready, my point? So first one is what, Nana? Elasticity. Elasticity is the ability of the material to regain its shape or its original position whenever the load is removed. Clear? Then coming to the ductility. What is meant by ductility? It is the ability of the material to deform under tensile loads or draw into wires. Clear? It possesses more tensile strength. Then coming to the malleability. This is the third property. The ability of the material to deform under compressive loads. What? It is the ability it is the ability of the material to deform under compressive loads or the ability of the material to drawn into sheets. Clear? Elasticity, ductility, malleability. So I am giving some time to take it down. Okay, hope you got. Take it down. Okay. Then coming to the next property, hardness. What is meant by hardness? So hardness is the ability of the material to resist indentation, penetration and the scratching. Clear? So I will explain you. See here what is meant by hardness. For testing hardness, we have different types of methods. Rockwell hardness, Brillen hardness testing. I will let you know in the later classes while coming to the destructive and non-destructive testing of the materials. Okay, so what is meant by hardness here? Say I am having this material. I am trying to scratch on this. If this material with which this body is made, it resists, then we call it as this material is harder. This material is harder. This type of harder materials has less ductility, less ductility. We're getting right. So this type of harder materials having less ductility. Clear? So first is what? Scratching. Indentation means, what is indentation means? With sharp point edge, if you are trying to penetrate on that, or if you are pushing small pointer on some body, what happens? If it is resisting, say needle, sewing needle, if you are trying to indent on some body, if that body is resisting that indentation as well, then we call it as the harder body. Any body which resists indentation, penetration, scratching is known as harder material. From this property only we are cutting the metals. Hardness can also be defined as, it is the ability of the material to cut other material. Clear? You are getting right. So due to this metal only, if you take any harder material, then go with the cut softer materials. The softer material easily means penetrate from that. Harder material we can directly cut on the softer material, we can cut with the harder material. That is the ability of cutting, can also defined by this hardness. Are you getting my point? So what is meant by hardness here? It is the ability of the material to resist indentation, penetration and the scratching, or it is the ability of the material to cut other material. Clear? So if we are having a ductile material, say made with a stainless steel, and harder material like HSS means high speed steel, we can cut this steel, means normal steel means mild steel, we can cut this mild steel with the help of this HSS. That is the cutting ability of the material to cut other materials. That can also we can define by this hardness. You are getting right. So what is meant by hardness here? It is the ability of the material, to resist the indentation, penetration and scratching and wear. What is meant by wear means, due to if two machine parts having relative motion between that, due to continuous relative motion in between that, the part may get weared out. Weared out means due to this relative motion the material get deformed, means dislodged. It is the ability to resist this dislogging of materials also, that is known as hardness. Clear? So what is meant by hardness here? It is the ability of the material to resist indentation, penetration and scratching and wear. Clear? So first one is what, Nana? Elasticity, ability of the material to regain its shape whenever the load is removed. Then ductility means what? The ability of the material to deform under tensile load, or the ability of the material to draw into wires. Okay. Malleability, the ability of the material to deform under compressive loads, or the ability to draw into sheets. Clear? The hardness means it is the ability of the material to resist the indentation, penetration, wear and the scratching, and it is the ability of the material to cut other material. Clear? Or the ability of material to cut other metals or other material. What, Dana? Ability to cut other material. Clear? So these are the four properties. Hope you got this. Okay. So I am rubbing it now. Here. You can check. We will go with other properties. Okay. We will go with the other properties. That is resilience and toughness. What, Nana? Resilience and toughness. For defining these properties, we will go with the first stress and strain diagram. Stress and strain diagram or load versus deformation diagram. See here on ordinate. On ordinate means y-axis. On y-axis. On y-axis, I am taking load, or we call it as stress. The thing stress I will explain you in the strength of materials. Okay, stress. For no sake time, go with the load. Okay, or the strain. What nana? Strain or deformation. What nana? Deformation. Deformation. First one is what? Load versus strain. Sorry, load versus deformation or stress versus strain diagram, or we call it as curve. For what? Mild steel. For what? Mild steel. Or we call it as sigma versus epsilon curve for MS. For what nana? MS, for mild steel. So say this is a specimen. This is the specimen what we are using for a tensile test. On what tensile test is done, mama? On what tensile test is done? UTM, right? So universal testing machine. It has two jaws, upper jaw and lower jaw, and lower jaw is moving one, upper jaw is stationary. Okay, in between these two we will fix the material and we will apply the load on lower jaw so that it will elongate in downward direction. What? It will elongate in the downward direction and produce the elongation, means a deformation in the body. Due to that, you will get properties. Clear? So what we are doing here, or it is, we will fix in vertical direction. Okay, I am drawing dog bone shape will be there. The specimen shape will be dog bone. Okay, see here we are applying force in this direction. Here it is fixed in this upper jaw. It will be fixed in this upper jaw. The specimen will be fixed in this upper jaw, means stationary jaw, and one more lower jaw will be there. It will pull it down. It will pull it down. It will pull it down. And this curve is obtained on the drum. Whatever the load is applied on that and whatever the corresponding deformation is going on that, this curve is obtained directly. The drum and other linkages. Okay, other linkages. So how it is obtained? So we are increasing the load now by pulling it. Due to increasing the load, what happens? This deformation also increases, right? Deformation also takes place in the body, right? So due to increasing the load, what happening here? This deformation also taking place. Due to increasing this load, this deformation also taking place. Up to some limit, this curve will be linear. Up to some point, I will let you know the point. This is the what? Linear. Linear means when the linear relation comes between any two parameters. Here we have the load and here we have the deformation. The relation is linear, means there is a proportionality, means you can check as it is increasing. As the load is increasing, when the load is 0, the strain is also 0. This is the 0 point, right? Origin. This is the origin. When the load is 0, the strain is also 0. Means the deformation also 0. As it is increasing, as the load is increasing, the strain is increasing. Up to some point, this point is known as proportionality limit. Proportionality limit means in this region, up to this limit, the load is directly proportional to deformation, or the stress is directly proportional to the strain. That is known as proportionality limit. That is known as proportionality limit. From this only we will draw the Hooke's law. Okay, this is what Anna? Proportionality limit. Say I am denoting it by A. We won't get exact curve as we are drawing here. We are magnifying and drawing it here. Okay, this is the point A. Point A is what, Nana? Point A is what? For sake of time I am rubbing this. Okay, this is what here. Point A. Point A is what, Nana? Point A is proportionality limit. What is meant by proportionality limit here? Within this limit, the stress is directly proportional to the strain. You are getting my point? So the load is directly proportional to the deformation. Within this limit means the linear relation will be there in between these. Then comes due to slight increase in this, one more point we will get, that is the B point, that is the elastic limit. What Nana? Elastic limit. You are getting right? So B means what? Elastic limit here. B is what? Elastic limit. Elastic limit. What we said, Nana, while defining the elasticity? Within the one load means whenever the load is applied on the body within that particular region or in limit, if the body regains its original shape, then the body is known as elastic. Then the body is said elastic, and the material with which it made is elastic material. So now we are defining B point as a elastic limit. Means if you apply, say, this is the load, right? This is the load. If you draw the horizontal line, you will get the load here. So whatever the load is here, say 200 newtons or 200 kilonewtons. 200 kilonewtons. I have applied the 200 kilonewtons load on this. Okay, and this is the point of elasticity. So on a body, if you apply below 200 kilonewtons of load, then the body is elastically deformed. If you increase this load beyond 200 kilonewtons, the body will be start deforming plastically. These stages will be there, Nana. You have to be careful here. See what we are doing here. If you increase the load beyond 200 kilonewtons, what happens? The body will start deforming plastically. Within this limit, the deformation will be elastical, and the deformation can be regained. Clear? The position can be regained. Okay, I am giving this example only. Okay, this is the okay. Now comes one more point, that is the yield point. This is the upper yield and this is the lower yield, specifying, see here, C and D points, upper and lower yields. So what is mean by yield here? What is mean by yield here means without any noticeable increase in the load, deformation takes place. Without any noticeable increase in the load, deformation takes place, that is known as yielding. Clear? That is known as yielding. You can check here, this is the C comma D are the upper comma lower yields. What is meant by yielding, Nana? Without noticeable change in the load, deformation takes place, then that is known as what, Nana? That is known as what? Yielding. That is known as yielding. Clear here? Then coming to the next, ultimate strength. This is the point E. Point is E is ultimate strength. Ultimate strength. So what happened here? This is the ultimate strength, means the body can't withstand the load beyond this. Say this is the 500 kilonewtons. 500 kilonewtons. The body can't withstand this beyond this 500 kilonewtons. That is the ultimate strength of this body. That is the ultimate strength of the body. This point is specified by E. That is the highest point, I mean the peak point in the stress strain curve. Ultimate strength. From now onwards, what happens? This curve will come down. Means what does indicates, Nana, here? What does indicates? Even though deformation is there in the body, but the load required for deforming from here means this point is less. We are getting point right here. This is the peak point, means 500 kilonewtons it required here, but from here the graph is coming down, the curve is coming down. Why? here what happens means, due to deformation, the area of cross section will be reduced for that particular specimen whatever we have drawn earlier here. What happens, the area of cross section will be decreased. Area of cross section will be decreased. I will give the clarification for you peoples. What is meant by stress here? Actually, stress means load upon area. For now sake, load upon area. Load upon area. Load upon area, right? So the stress is less, means whether this load has to be less or area has to be more, then only the stress will be less. Clear, right? So what happening here after this point, ultimate tensile strength, what happening in this point, load is decreased. Load is decreased means simply stress is decreased due to what? Not area decrement. Area decrement. Area decrement, due to decrement in the area, the load required to deform it is less. Deform it less. Clear? If you got this point, okay, then come here. This is the last point, fracture. F. What, Nana? Fracture. F means what? Fracture. Fracture point means at this point the body will break. This point the body will break. Now this is the total area under the stress strain curve or the load versus deformation curve, right? This is the total area. This is the total area under this curve. I am dividing this area into two parts now. See here, what, Nana? This is the O to B is one, and from here to here, from here to here, O to F, second area. Clear? What is, Nana? This is the first area I am dividing here. This is the first area from O to B, first area, and one more area O to F. O to B, O to F. Two areas we have here, right? Two areas we have here. So you can check here, O to A, O to B is the energy stored. See here, the energy absorbed by the body by applying load within this elastic limit. What is B, Nana, here? Elastic limit. Clear? So the load absorbed or the energy absorbed. Clear? Whenever the load is applied on the body, it will get absorbed the energy. So the energy absorbed within the elastic limit. Clear? Within the means the energy absorbed from O to B is the resilience. What, Nana? Resilience. This property, resilience property, the spring will have. Spring should contain resilience, means it has to deform elastically. It has to deform elastically. Clear? So O to B means what? The resilience. The energy stored within the elastic limit is known as resilience. And the energy stored within the plastic limit and the elastic limit as well, that is known as this toughness. What, Nana? First one is what? Elastic limit, within the elastic limit, and second one is elastic limit and the, that's why I drawn two areas here with blue ink and the black ink. You can check here, this is the black ink area is only for what? Elastic limit. Within the elastic limit means the resilience, and from O to F, that is the toughness. Okay, hope you got this diagram. Keep it with you. In the next class we will start from here itself, resilience and the toughness. Mind what is meant by proof resilience, modulus of resilience, and what is the amount of energy stored whenever the body is loaded. I will let you know in the next class. And we left with the creep and the fatigue, toughness and the resilience. Okay, we will cover it in the next class. Okay, hope you got all these things. Okay, but do like, share and subscribe to our channel and comment below in the section, comment section. Okay, thank you, bye.